You know those projects, the really big ones, the ones that feel like they've got, I don't know, a million moving parts, everything depends on everything else. Things are changing all the time.
Oh, yeah. The kind where keeping it all straight in your head feels basically impossible.
Exactly. Now imagine trying to manage that, but you're an AI, specifically like a large language model, an LLM, with what amounts to a pretty limited short-term memory. How on earth do you even begin to tackle something massive, like, say, a game development project spanning years or some sprawling software application where context is absolutely everything? Remembering the state of every little piece, it seems non-negotiable, right?
Well, that's the absolute core challenge with the current generation of LLMs when you try to push them beyond, simple Q&A or just single-turn tasks. They are fundamentally largely stateless,
Stateless meaning.
meaning each interaction is almost like starting fresh. Or they have a very, very small window of memory, what's technically called a finite context window. Think of it like having this incredibly brilliant assistant, super smart, but they can only remember, say, the last 5 things you told them, no matter how complicated the overall project is.
Right.
You feed them information, they process it brilliantly, but that knowledge, that state, it doesn't inherently stick around between prompts or over long periods.
So you can't build up complex understanding over time easily.
Precisely. And if you try the obvious thing, like giving them one single massive document with everything about the project, well, that just overwhelms that tiny memory window almost immediately. You simply can't maintain context over these long, complex interactions or across multiple different tasks that need different pieces of information. It's been a huge barrier to using AI for really deep, sustained collaboration on anything with genuine complexity.
Yeah, I can see that. You could ask it to maybe write a specific function in code, sure. That fits in the window. But could you ask it to manage the status of that function across, say, 10 different files, and then cross-reference that status with the overall design principles you discussed last week, and maybe update a detailed checklist somewhere else, and know why it's doing all of that based on some long-term vision document? That
Yeah,
seems like a different league.
it absolutely is.
Hmm.
That requires a persistent, structured understanding of the project's current state, its history, its goals, all the things that fall out of that tiny context window.
And that brings us neatly to the, well, pretty radical solution we're going to be deep diving into today. It's based on a whole stack of sources that one of you actually shared with us.
Yeah, this looks fascinating. It's a multi-file roadmap system, and it's specifically designed, it seems, to act as a kind of externalized brain or memory for an LLM. The whole point is to let it manage these truly complex projects by tackling that statelessness problem head-on.
So, our mission for this deep dive, we're going to unpack this system layer by layer. We want to understand how it actually works. What are the different pieces doing? How does it overcome those LLM limitations we just talked about in practice?
And maybe the most interesting bit, what does the AI itself think about this whole setup after actually working inside it? That perspective could be really revealing.
Absolutely. We've got a bunch of markdown files here detailing the system structure, defining specific roles and directives for the AI, tracking status updates, outlining technical stuff, and yes, we even have that AI evaluation from a Gemini model.
So we've got the blueprints, the user manual, the progress reports, and the performance review, all rolled into one.
Pretty much. We're going to pull insights from all of it to really get our heads around this approach to human-AI collaboration on complex stuff.
Okay, let's dive in then. Where should we start? Maybe with the foundation, how it tackles that state problem.
Yeah, let's start there. The foundation of this entire system seems to be tackling that finite context window, that statelessness of LLMs. Like you said, it's like trying to hold the entire plan for a multi-year project. Every single requirement, every bug report, every task that's done, every dependency, all in your short-term memory at the exact same time.
Which is impossible for humans, let alone current AIs. For an LLM, that context window is its short-term memory for any given interaction. If the sheer volume of project information exceeds that window, poof, it forgets things it was told just moments ago, relatively speaking.
So the cleverness here, the core idea of the system.
It's brilliant, really. It lies in not trying to cram everything into that single limited context window. Instead, it externalizes the project state, its knowledge, into a structured, persistent memory.
Externalizes, meaning it puts it outside the AI's immediate processing.
Exactly. It's spread across multiple interconnected files. Imagine, instead of just whispering instructions one sentence at a time to your assistant, you give them a really well-organized project binder or maybe a shared digital folder, complete with dividers, cross-references, linked documents.
Okay, I get that analogy.
This structure allows the AI, or indeed a human collaborator, to access and load only the specific, relevant pieces of information needed for the task right now into its immediate context window. It can focus on one document, one section, without losing the thread of the overall project, because that overall understanding is stored externally, ready to be referenced.
Right, so it can load just the vision document when thinking about strategy, or just the bug list when debugging, without needing the entire project history loaded simultaneously.
Precisely. And the starting point, the way you navigate this external brain, the kind of central hub or index, is this file called 00row roadmap overview.md.
And the sources describe this one as the lead project navigator and information hub. Sounds important.
It really is.
Yeah.
It acts as the system's main table of contents, but also its primary set of operating instructions for the AI. The source lists its core directives. First, help the AI understand the overall scope and structure of the whole project.
Like a sitemap.
Sort of, yeah. Second, guide the flow of information using hyperlinks to the other specific roadmap files. Third, maintain project cohesion, basically, reminding the AI that a change in one file might have ripple effects elsewhere.
Okay, interconnectedness.
Fourth, and this is crucial, ensure the AI adheres to the specific contextual instructions of these unique personas that are defined within each of the other files.
Ah, so different files might have different rules or perspectives baked in.
Exactly. And finally, just generally facilitate efficient development by helping the AI quickly locate whatever information it needs.
Makes sense. There's also this really stark warning right at the top of this overview file, isn't there? It feels pretty fundamental for working with AIs like this.
Yes, it's emphasized. Do not make assumptions about requirements. Always refer to the detailed documents. Brevity at the expense of clarity will lead to project failure.
Wow, okay, so no winging it. Stick to the script, basically.
It sets a tone of rigorous adherence to the documented truth within the system. It establishes the ground rules. The AI isn't supposed to guess or, extrapolate wildly beyond what's written down. Its main job in this framework is to process and act upon the documented information that's provided in these files.
Got it. The overview also mentions project phases, right? IP, S, E, C.
Yeah. Initial planning, IP, strategy S, execution E, and cleanup C. And this isn't just like arbitrary project management fluff. These phases are actually critical because they guide which of the other roadmap files are most relevant or active at any particular time. It helps the AI focus its attention on the right information for the current stage of the project.
Okay, so the system knows we're in execution phase, so files X, Y, and Z are most important right now.
That's the idea. And the overview then lists out the main files in the system, giving a quick rundown of what each one is for, its phase relevance, and critically, a specific LLM role hint for the AI.
Ah, the personas. Let's run through those.
Okay. First is AO1 Project Concept and Vision.md. This is the what and why. Core vision, target audience. Most relevant during initial planning and strategy. The AI's role hint here is vision keeper and concept analyst.
Keeping the big picture in mind.
Okay. Then 02 Core Components Features and Checklist.md. This is the detailed technical blueprint. Components, features, their status, dependencies. Super relevant during IPS, E, and C, basically all the time once things get going. The role hint is lead architect and feature integrator.
The details person. Got it.
Odo 3 Methodology and Guidelines.md. This defines how the work gets done. Principles, risk management, quality assurance. Also relevant across all phases. IPS, E, C, role hint. Process optimizer and QA strategist.
Process police, kind of.
Maybe. Yeah. In a good way. Then 04, Project Status and Priorities.md. This is the dynamic live status board, what was just completed, known issues, current priorities. Very important during strategy, execution, and cleanup. The AI's role, Agile Project Coordinator and Issue Resolver.
A traffic controller.
Yeah, managing the day-to-day flow. CO5 Technical Details and Performance.md. This is for deep dives into the technical architecture, performance metrics, optimization strategies, relevant in strategy, execution, cleanup. Role, Solutions Architect and Performance Engineer.
The engine tuner.
Good one. And finally, 06 Roadmap Completed.md. This is the historical log, the archive of everything significant that's been finished, relevant across all phases as a reference. The implied role here, based on the overview, is project historian and archivist.
Okay, so a whole team of specialist personas for the AI, depending on which file it's looking at.
And that LLM role hint, for each file. It's particularly clever. It's not just a label, it's a core part of the prompt engineering strategy. When you direct the AI to a specific file, like file R1, you also give it that hint. Okay, now reading this, think like a vision keeper.
Oh, so you're telling it how to think about the information.
Precisely. You're priming it to filter the information, interpret it, and generate responses from that specific perspective, rather than just giving a generic answer.
And how does it know to switch roles? Is that automatic?
Not quite automatic, but very explicit. The overview document outlines what it calls the transition protocol. It states basically, whenever you open a linked roadmap file, your very first action is to read and internalize the system prompt and core directives section right at the beginning of that specific file.
So it has to consciously load the rules and persona for that document before doing anything else with it.
Exactly.
Hmm.
It ensures the context switch is deliberate and intentional. The AI doesn't just glance at the file, it actively engages with the instructions and persona defined within that file. It's like the fundamental handshake of the system, ensuring it wears the right hat and follows the right rules for that part of the project's brain.
Okay, that makes a lot of sense. It forces the focus. Speaking of the project's brain, let's focus maybe on its soul. File 01, the concept and vision.
Good place to go next. This file, 01 project concept and vision.md, is all about that fundamental what are we building and the guiding why are we building it.
The vision keeper role.
Right. As the sources detail it, the AI's explicit persona here is the guardian of the project's core identity and visionary analyst. It acts as both the vision keeper and the concept analyst. Its primary focus is squarely on the fundamental concept, the core problem being solved, and crucially, the intended user or player experience.
And its directives within this file, they reinforce that function, right?
They do. Understand and internalize the vision deeply. Ensure strategic decisions and new feature ideas actually align with this core vision. Analyze how proposed features contribute to key milestones, specifically related to the user or player experience. Clarify the vision if there are any ambiguities, and maybe most importantly, act as a guard against scope creep.
How does it do that?
Guarding scope creep.
By flagging ideas or changes that seem to deviate from the established core vision documented right there in File 01.
Okay, let's make this concrete. The sources mention a voxel-based colony simulation game example. How would File 01 work for that?
So the O1 file for that game would contain its core vision statement, something like a colony management game inspired by RimWorld, but featuring enhanced 3D voxel-based building and mining, rich colonist AI simulation, and deep crafting and research systems.
Okay, pretty clear.
Now, the AI, acting as the vision keeper persona, uses this specific description as its yardstick. If someone, maybe a developer or designer, proposes adding, I don't know, a complex real-time strategy combat system with buildable tanks and aircraft, which sounds kind of cool, but maybe not very RimWorld-like.
Exactly. The AI, in its vision keeper role, checks that proposal against the core vision. Colony management, deep crafting, rich colonist AI, similar to RimWorld. It would likely flag the tank combat system as a potential deviation. It might say something like, this seems to shift focus away from internal colony simulation and local threats towards large-scale warfare, which isn't part of the core identity outlined in File 01. Should we reconsider if this fits the intended player experience?
So it uses the documented vision to challenge ideas that don't align. It guards against scope creep and feature bloat that could dilute the game's original appeal.
Precisely. This file, and the AI persona associated with it, function like the project's central guiding star. It's constantly asking, implicitly or explicitly, does this fit? Does this serve the core vision and the intended user? It ensures development stays true to that initial spark.
Okay, that makes perfect sense. That covers the high-level map, the overview, and the project's guiding vision, its soul. Now let's transition into the really detailed what the project's internal structure, the components. That would be File 02 core components, features, and checklist.md, right? The canonical technical blueprint.
Exactly. We're moving from the why to the very granular what. This file is where the system's knowledge gets incredibly detailed. And notice the AI's persona shifts significantly here. It's now the lead architect and feature integration lead.
It should hat entirely.
Completely. It adopts roles like systems architect, feature analyst, and progress tracker. The focus here is all about precision, meticulous detail, and understanding the real nuts and bolts of the project.
And its directives in this role reflect that focus on detail.
Absolutely. Achieving blueprint mastery, which means an exhaustive understanding of all the components and features listed. Performing dependency analysis, understanding how different systems rely on each other, which is critical for planning and debugging. Facilitating progress tracking, using those checklists. helping with feature elaboration, breaking down big, high-level ideas from file 01 into smaller, concrete implementation tasks, identifying integration gaps between different systems, and maintaining technical feasibility awareness, knowing when a proposed feature might bump up against technical limits and requires consulting file 05.
So this is basically the project's engineering Bible, the single source of truth for what's actually being built, feature by feature, system by system.
That's a great way to put it. Let's look at the Voxwell game example again, just to see the level of detail it tracks and think about why this level of detail is so useful for an AI acting as an architect. It lists the major game systems, things like the workstation system, the colonist management system, research system, job and task system, UI, performance, narrative, combat. Having these clearly defined categories helps the AI organize its understanding of the project's inherent complexity. It's not just one giant list.
And within each system, it lists specific features and, crucially, their status using those little check boxes, right? For not started, X for implemented, and I think there's an X in progress too.
Yes, exactly. Not started, X in progress, X implemented. This is where the system tracks the actual ground truth of the build progress.
So the AI can see at a glance what's done, what's being worked on, and what hasn't even started yet.
Right, and think about the insight this provides the AI. It's not just reading a vague description, it's seeing the live, detailed spate. For instance, the source shows the workstation system checklist. It lists things like generic workstation class X implemented and workstation-based crafting X implemented.
Okay, so core crafting mechanic is done.
The AI knows that, but then it also notes specific plan structures, like automated hopper not started. So the AI, as architect, understands this is a planned feature part of the design, but it doesn't exist in the code yet. It knows not to rely on it.
That colonist management system checklist you mentioned from the source seemed like a really good example of tracking not just progress, but also issues.
It really is. It notes autonomous AI agents X in progress with a comment, BT system ported. Behavior trees, or BTs, are a common technique for game AI decision-making, like flowcharts for behavior. So the AI sees, okay, the basic framework for agent AI is there. But then the next line is job-based behavior trees in progress. Notice the exclamation mark, and there's a critical note. P-game's dynamic tasking is missing.
The owl. That signals a problem.
Exactly. It tells the AI, hold on, this isn't just in progress. There's a known problem or a critical piece missing here. The AI architect immediately understands there's a functional gap. Colonists can't properly get and execute tasks based on their assigned jobs, even if the underlying AI decision-making structure is partially ported. This isn't just listing features, it's tracking the quality and completeness of the implementation in real time.
And you mentioned the inventory logic entry showed how the status can change.
Yeah, that was interesting. In the source, it's initially marked it, not started, with a note explaining that the current code base has a placeholder, unlike older functional code. But then later in the same source document snapshot, it's marked X implemented.
So it got fixed.
It seems so, but there's a crucial parenthetical. Must be verified. This highlights the need for human verification, which the system's directives encourage. But it also shows how the document captures the journey of a feature from identified gap to being worked on to marked as implemented, but still needing confirmation. The AI architect sees this history, understanding the potential fragility or need for extra testing around recently completed critical systems like inventory.
That makes sense. There was also a really stark example in the job and task system checklist, wasn't there? Something marked as critical.
Yes, that was a big one. The whole system is marked down. Not started initially, with a very critical note. Core task, execute logic, largely missing placeholder.
Oof. That sounds bad.
It's a major red flag for the AI architect. The checklist then lists specific fundamental colonist tasks, like task mind block, eat food task, craft item task, construct task, and explicitly states their underlying logic is just placeholder code. It doesn't actually do anything.
So colonists can't mine, eat, craft, or build.
Effectively, no. This immediately tells the AI that fundamental gameplay loops are completely blocked. When the AI is asked to help plan new features or debug existing ones, it knows this is a critical bottleneck. It directly links this missing logic to why essential colonist roles like miner, woodcutter, crafter, cook, builder are also marked other, not started or blocked elsewhere in the checklist. It understands the dependency chain.
So it's not just a list, it's showing the critical path or lack thereof.
Precisely. The UI checklist is another good example of tracking different layers. It notes that core UI panels are implemented X and connected to live game data for colonists, crafting, research, etc. That's good.
Right.
But specific interaction paradigms, like contextual menus for interacting with objects in the world, are still marked, not started. So the AI knows the basic display foundation is there, but the interactive user experience layer still needs significant work.
Okay. And performance and technical aspects are in this file too.
Yes, Section O2 provides a high-level view connecting performance goals to specific systems.
Mhm.
For example, pathfinding is marked X, implemented using A3D, a standard algorithm for finding paths, adapted for a 3D voxel world. That's the core tech.
But performance might not be optimized yet.
Right. Specific performance optimizations, like LOD, level of detail, which reduces the complexity of objects far away from the camera, are listed as not started. The AI architect sees the core piece as functional, but the necessary efficiency work is still on the to-do list.
It's incredibly detailed. This file must be huge for a complex project. And it ends with a system dependencies section. Why is that separate?
That section is absolutely crucial, especially for an AI architect or project manager. It explicitly lists out which systems rely on other systems to function. Like, Colonist AI depends heavily on pathfinding. They need to know how to get around. Crafting depends on the workstation system, the item database, recipes, colonist interaction logic. And the example notes, the narrative system depends on almost all other systems because it needs information about colonists, their moods, buildings, resources, recent events, combat outcomes, etc., to generate meaningful story events.
Ah, okay. So mapping those dependencies allows the AI to understand the ripple effects of changes or delays. If pathfinding is broken, colonist AI is blocked.
Exactly, and it helps prioritize tasks. You often need to build the foundational systems first before you can build the systems that depend on them. This dependency map makes that explicit for both the AI and the human developers.
So File O2 is the intensely detailed technical blueprint, tracking status, dependencies, known gaps, feature lists. It enables the AI to function as a really informed technical expert and planner. Okay, so if O2 is what needs to be built, that leads us to how we should build it. And that's Files O3, right? O3 methodology and guidelines.md.
Correct. This file dictates the development process itself. And again, the AI's persona shifts. Here, it's the lead process optimizer, QA strategist, and risk mitigation advisor.
Quite the title.
It implies a focus on best practices, robust testing efficiency, and importantly, anticipating potential problems. Its specific roles listed are process manager, QA strategist, and risk analyst.
And its directives match that focus.
They do. Things like champion development principles like modular design, facilitate structured planning, the sources mentioned using a planning scratchpad for this, proactive risk management, guide comprehensive testing, the sources stress testing each system thoroughly before integration, promote modularity and maintainability in the code, and promote documentation excellence.
So it's pushing for good engineering habits.
Absolutely. The core development directive section reinforces this. It explicitly lists principles like modular design and separation of concerns, comprehensive commenting and documentation, mentioning that these roadmap files themselves are just the starting point for documentation, and incremental development and thorough testing. That emphasis on testing each system before moving on seems key to their methodology. Build a solid foundation, piece by piece, and verify it works.
There's also a directive in there, highlighted in bold in the source. Record all progress and plans in the appropriate roadmap files.
Yes, that's a critical feedback loop in the whole system design. Progress isn't just made. It must be captured back into this shared external brain, into the correct file, so that everyone, human and AI, can see the current state and use that information. It keeps the external brain accurate.
Okay. And a big part of how you develop well is anticipating what could go wrong. File O3 includes that detailed risk assessment and mitigation section, right?
Exactly. This is where the system actively encourages foresight, planning for potential pitfalls.
What kind of risks did the voxel game example identify?
The sources list several specific technical risks. Things like voxel rendering performance, potentially suffering at large scales, the inherent complexity of robust save-load systems in a dynamic world, AI pathfinding performance becoming a bottleneck with many agents, memory management, especially if the world is meant to be conceptually infinite or very large.
These sound like common, hard problems in game development.
They are. But the file doesn't just list the risks, it lists proposed mitigation strategies for each.
Like what?
For rendering performance, it lists standard graphics optimization techniques. LOD, frustum culling, not drawing stuff you can't see, batching draw calls, maybe GPU instancing. For save load complexity, it suggests incremental saving, data compression, robust serialization methods. For pathfinding performance, maybe hierarchical pathfinding, caching paths, using multi-threading. For memory, aggressive unloading of unused world chunks, efficient data structures, streaming assets in.
So standard solutions, but documented and planned for.
Right. It even includes risks related to workflow, like content creation pipeline inefficiency, with mitigations like having clear design documents, using iterative balancing, building editor tools, and it notes that key future mitigations like procedural content generation and data-driven design are planned, but still not started.
And fascinatingly, it explicitly lists a risk that's unique to this kind of setup: LLM assistant misinterpretation.
Yes, I found that really interesting too. It acknowledges the risk that the AI itself, despite this whole elaborate system, might still misread the situation, misunderstand a requirement, or generate incorrect or subtly flawed output.
That's quite self-aware. What are the mitigations for that?
They're crucial for any serious human-AI collaboration. First, provide clear contextual prompts starting with the 0-0 overview and always linking to the specific subdocuments needed. Second, and this is emphasized, human oversight and review of LLM-generated content.
Ah, the human stays in the loop.
Right.
Critically.
Absolutely critical. And third, always use the roadmap files themselves as the ultimate source of truth to verify any AI outputs or suggestions. It explicitly builds in the need for human validation and guidance. The AI is a powerful assistant, but not infallible, and the system acknowledges that.
Files 03 also seem to touch on things like the content creation pipeline recipe balancing, biome design, event design processes.
Yeah, it shows attention to the workflows needed to actually fill the game with content, beyond just the core engine code. Even if the tools for those workflows, like procedural generation, aren't fully built yet, the process itself is being considered and documented.
Okay, so Philo 3 covers the process, the principles, the planning rules, the testing strategy, anticipating risks, and outlining workflows. It's the rulebook for how to operate safely and effectively within this development environment.
Well put, it defines the how.
Now, how does the project keep track of its day-to-day reality, the constant flux of development? That seems like the job of O4 Project Status and Priorities.md, which the source called the Operational Nerve Center.
That's exactly its role. This is designed to be the most dynamic file on the whole system, reflecting the project's current active state. And the AI's persona shifts again. Here, it's the Agile Project Coordinator and Proactive Issue Resolver.
So like a project manager or a scrum master?
Precisely. Its listed roles include Project Manager, Scrum Master, and Issue Tracker. Its focus is squarely on the immediate past, what just got done, the present, what are we working on now, what's broken, and the very near future, what's the absolute next priority.
And its directives are action-oriented, presumably.
Very much so. Track current work specifically, last completed items, currently active items, and next items in the queue. Proactive issue management, documenting, tracking, and managing the list of known issues. Facilitate agile prioritization. This is key. It needs to synthesize input from dependencies from follow 2, urgency, strategic importance from follow 1, and guidelines from follow 3 to determine what's most important now. Progress reporting and checklist synchronization, meaning when work gets done here, it's responsible for ensuring follow 2's checklists get updated. And future item curation, managing the backlog of ideas that aren't immediate priorities.
This file sounds critical for keeping things moving. The sources gave a snapshot from the voxel game example, right? What were the key parts?
Yeah, the source highlighted the most critical sections within File 04. The list of next items to work on, prioritized, and a summary of critical implementation gaps from in-depth review.
Okay, so this is where the AI, acting as project coordinator, looks at the blueprint, O2, the known issues tracked in O4 itself, the dependencies, O2, the vision, O1, and decides what absolutely needs to happen next.
Exactly. And the critical next tasks listed in the source directly address those fundamental gameplay blockers we saw identified back in File 02.
Which were?
Implement port inventory class logic, critical. Port core task execution logic, the execute methods, critical. Port implement dynamic tasking AI and general actions, critical.
Wow. Okay, so those items from the File 02 checklist bubble right up to the top of the priority list here in File 04.
Precisely. File 04 is the place where these critical implementation gaps, identified through analysis, likely involving both human review and maybe AI assistance cross-referencing the files, are explicitly flagged as the absolute highest priority work items. The AI, if you asked it, what should we work on next, would point directly to this section, having synthesized information from across the system.
That's powerful. File 04 also listed a lot of other specific known issues, didn't it? Beyond those critical blockers.
Oh yes, the source details quite a few. It shows the granularity of the tracking. Issues ranging from subtle inconsistencies, like colonist entity inventory handling inconsistency, to outright bugs, like a persistent indentation error in core game.py, to clearly missing features, like structural integrity not implemented, to limitations of the tools being used, like headless environment limitations impacting automated testing,
So really specific stuff.
and even problems specific to certain AI behaviors, like specific BT failures, hunger, energy fulfillment failing tests. It's not just a vague bugs exist list. It's detailed notes on specific system failures, potential inconsistencies between different versions of the code, like a note about direwolf environmental effects mentioned in the source, and known limitations. The AI, wearing its issue resolver hat, has access to this detailed list to help debug, track status, and prioritize fixes. It's effectively the project's live bug tracker and task list rolled into one file.
And O4 also tracks work completed recent, you said.
Yes, and the source lists a significant volume of tasks marked as recently finished in that snapshot. Things like ported inventory logic, ported core task execution logic, ported dynamic tasking AI.
Wait, those are the critical next items.
Exactly. This snapshot seemed to capture a moment just after a major push to fix those core blockers. It also lists things like structural integrity implemented, confirming it was recently completed, even though it might have been on an older known issues list, showing how quickly this file updates. Ported combat faction trap systems, implemented save load, event storyteller systems, and a whole lot more.
Wow, so that list shows a huge amount of recent progress.
It does. And that work completed list is vital. It shows both the AI and the human team what progress has just been made. It provides positive reinforcement and clarity. It also acts as the direct source for populating the historical archive, File 06. Seeing items literally move from the next items or known issues list into the work completed list within File 04 really demonstrates the dynamic nature of this file. It truly is the project's live pulse, the dashboard for real-time status updates.
Okay, that neatly wraps up the core operational files, the blueprint in O2, the process in O3, and that dynamic live status in O4. Let's shift gears slightly and move to the deep engineering details with File 05 performance technical details.md.
Right. This file is where the system really gets into the nitty-gritty of the technical implementation choices, specific performance goals, and detailed architectural decisions. The AI's persona here, it's the chief performance engineer and lead technical solutions architect.
Sounds very senior, focused on.
Focused squarely on efficiency, scalability, stability, think milliseconds, memory usage, frames per second, and the underlying technical foundation that makes it all possible.
And its directives in this file align with that technical focus, I assume?
They do. Things like champion specific performance targets, perform deep dives on technical architectures of key systems, drive optimization strategies, validate the technical feasibility of proposed solutions or features. Can we actually build this efficiently? Innovate technical solutions where needed, and maintain technical accuracy and depth in its analysis and any recommendations it makes.
So, ensuring the project is built on solid, efficient engineering, how does it track performance?
Well, the sources use examples from a more generic project to illustrate the types of quantifiable goals tracked here. Things like target API response times, maximum memory usage thresholds, minimum database performance metrics, target front-end performance scores, like load times.
Okay, so for the voxel game, this file would have similar but game-specific metrics.
Exactly. It would contain specific targets like, say, maintaining a minimum of 60 frames per second, FPS, under typical conditions, ensuring the simulation step time consistently takes less than, say, 16 milliseconds, and defining acceptable total memory usage caps for different world sizes or numbers of colonists. The AI, in its performance engineer role, uses these hard numbers as benchmarks to evaluate technical decisions, identify bottlenecks, and track optimization progress.
File 05 also includes architectural deep dive sections, right? The source used an asynchronous job queue example.
Yes, and that example demonstrates how File 05 serves to document complex technical systems in detail. The job queue concept is explained clearly. It's about offloading heavy or time-consuming tasks, like complex calculations or file I/O, to background processes so the main application or game remains responsive.
So the game doesn't freeze while saving, for instance.
Potentially, yes. The example details the mechanism, its benefits, responsiveness, scalability, resilience, and notes its status as not started in that generic project context. For the voxel game, File O5 would contain similar deep dives explaining the detailed architecture of, say, the multi-threaded voxel rendering engine, the specific format and process used for save load operations, or the intricate design of the AI storyteller system. It provides both the AI and the human developers with the detailed technical context needed to understand how these key systems actually work under the hood.
And it also lists things like planned optimization strategies.
Right. The generic source mentioned examples like database query optimization strategies or specific front-end asset caching plans. Files O5 is where these planned technical improvements are documented.
And data persistence architecture notes.
Yeah, detailing the current state and any planned enhancements for how the game saves and loads its state. This might include recognizing current issues, like maybe save files becoming too large. Large JSON payloads was mentioned in the generic example, or challenges with maintaining compatibility between game versions, versioning challenges, and outlining planned enhancements, like perhaps adding data pagination, using a more efficient serialization format, or implementing a caching layer.
So File O5 is essentially the project's detailed technical reference manual. It empowers the AI when wearing its technical architect or performance engineer hat to understand the deep engineering challenges, the specific goals, and the planned solutions.
Exactly. It bridges the gap between the feature list in Files O2 and the actual code and infrastructure.
Okay, that covers the deep tech. What about the history? We have one file left, 06roadmapcompleted.md, the project's historical logbook.
Right, the final piece of the puzzle. This file is curated by the project historian and archivist, a role that was implied back in the overview file, 000. Its purpose is pretty straightforward. Provide a permanent, detailed, and verified record of all significant features, milestones, and potentially major refactors that have been successfully completed, tested, and integrated.
So it's the official history of what's been achieved. What do entries look like?
The examples given in the source, again using a generic project context, were simple but clear entries like basic user login implemented, initial database schema created, project boilerplate setup. It also showed a section for general maintenance and refactoring, logging things like refactored authentication service or upgraded dependencies.
So both new features and significant behind-the-scenes work get recorded.
That seems to be the idea. It serves as the project's official change log and list of accomplishments. Items are typically moved here from that work completed recent section in File O4 after they've been fully verified and are considered stable and done. Unlike the very dynamic File O4, File O6 is a less frequently updated archive. It provides a stable, historical reference point for what has been achieved over the project's lifetime.
Okay, amazing. We've effectively navigated the entire structured brain laid out in these files from the high-level overview and vision, down through the detailed blueprint, the process guidelines, the dynamic live status, into the deep technical engine room, and finally, the history books. Now for what might be the most fascinating part. What does an AI that has actually used the system think of it? The sources included that evaluation from a Gemini model that interacted with these roadmap files.
Yeah, this is where the rubber really meets the road, isn't it? According to those source files, the ones titled Gemini Response.md and Gemini Thoughts.md, the LLM's feedback was, well, overwhelmingly positive. It apparently found the system genuinely impressive and even described it as a fantastic piece of engineering.
Wow, okay. That's incredibly validating for the whole concept, coming straight from the AI user itself. What specific things did the AI highlight as the major advantages? What did it like so much?
It identified several key strengths, kicking off with what it apparently called the most brilliant part of the whole setup, solving the core LLM weakness. State and context.
Ah, the very problem we started with.
Exactly. The LLM explicitly recognized that this multi-file roadmap system successfully externalizes the project state, effectively acting as that persistent structured memory we talked about. It saw this approach as a massive leap in efficiency and accuracy.
Why efficiency and accuracy?
Because the system allows a user, or another AI, to direct it to just the specific relevant files needed for a given task. It only needs to load the necessary context into its limited window, instead of requiring the entire project history to be re-explained in one giant, overwhelming prompt every single time. It understood intuitively that this structure bypasses its own fundamental finite context window limitation.
That's incredible. So the AI itself feels smarter, more capable when it has access to this kind of external structured memory. What else did it appreciate?
The second point was the structured role-playing for high-quality output. The LLM found those explicit system prompts and personas defined at the start of each file incredibly effective.
The vision keeper, the architect, the coordinator.
Right. It understood that these instructions weren't just labels, they actively primed it to think with a specific mental model appropriate for the information in that file. Whether it was the careful, big-picture strategic focus of the vision keeper, the detail-oriented technical mindset of the lead architect, or the efficiency and process focus of the performance engineer.
And that made a difference to its output.
Apparently, yes. It felt that this explicit guidance prevented it from giving generic, wishy-washy answers and instead led to much more specific, role-appropriate, and valuable responses.
That's a really powerful insight coming directly from the AI, that explicitly telling it how to approach and interpret information fundamentally changes the quality and relevance of its output for the better.
It really is. It underscores that it's not just about what information you give the AI, but critically, the frame or perspective through which you ask it to process that information.
Okay, what was the third point it liked?
Excellent separation of concerns. The LLM actually appreciated that the system applied good software engineering principles to the information itself, keeping different types of project knowledge, separate vision in O1, blueprint in O2, process in O3, status in O4, technical details in O5.
Like modular design, but for documentation.
Pretty much. It saw that this modularity made the whole system highly efficient. Why? Because it could focus its attention on one specific area, like investigating a bug listed in file O4, while still being able to quickly and easily reference connected information in other files when needed, like checking the dependencies in file O2 or reminding itself of the original vision in file O1.
So applying good design principles to the AI's information environment makes the AI itself more efficient and focused. Interesting. What else?
Fourth, it recognized the system as a true human-AI collaborative framework. This was key. The LLM understood that this wasn't just a complex set of instructions for it to follow in isolation.
It saw itself as part of a team.
It seemed to. It explicitly viewed the files as a shared workspace, a place where humans update status and verify work. The AI helps with planning, maybe generates code or content based on the files, and then humans update the checklists and logs accordingly. It felt this collaborative process created a vital single source of truth that both the human team members and the AI could rely on and actively contribute to.
So it didn't feel like just a tool being commanded, but more like a genuine partner working within a shared environment defined by these files.
That's the impression, yes.
Yeah.
And finally, the fifth point was scalability and maintainability. The LLM felt that for complex, evolving projects like that voxel game example, this multi-file system was perfectly scaled and fundamentally built to handle complexity long-term.
It saw that the structure itself wouldn't collapse under the weight of a growing project. It could scale.
Exactly. It felt the design could grow and adapt as the project added more features, more details, more history, without the core organizational structure breaking down.
Did the AI mention any downsides or challenges?
It did, briefly. It noted two potential challenges. One was synchronization overhead, basically, the effort required to keep all these different files consistent and accurately reflecting the current reality. If one file gets updated, related files might need changes too, and managing that takes effort.
Yeah, keeping everything in sync manually could be tedious.
Right. And related to that, it mentioned the need for tooling automation to help manage this overhead. It implied that doing all the updates purely manually could become burdensome on a very large project. But, and this is key, it reinforced that the fundamental structure and concept of the system were sound and highly effective. The problem wasn't the design, but potentially the manual labor involved in maintaining it at scale without good tools.
That makes sense. The AI's conclusion was pretty striking, wasn't it? Something about a shared workspace.
Yes, it said, this system isn't just a set of instructions for me, it's a shared workspace. And perhaps even more profoundly, it's not just a prompt, it's a development methodology centered around the LLM.
Wow, that really captures the shift in thinking, doesn't it? It's moving beyond just crafting clever individual prompts towards designing an entire workflow, an entire information environment around the AI to enable much deeper, more complex collaboration.
That's exactly how I read it.
And importantly, this whole concept isn't just a theoretical exercise based on these specific roadmap files we've been discussing. The sources actually point to a real-world framework available on GitHub that seems to embody very similar principles. Something called the Klein Recursive Chain of Thought System, CRCT.
Right, the README for that project describes it as a framework specifically for managing large-scale Klein projects within VS Code, using the Visual Studio Code editor and its file system. And it explicitly leverages a multi-file recursive approach for interacting with LLMs.
So people are actually building tools based on this idea. And looking at the key features listed for CRCT and its READM, you see these incredibly direct parallels to the strengths the Gemini AI identified in the roadmap system we just discussed.
Like what?
Well, things like recursive decomposition, breaking big tasks down into smaller subtasks, represented by files or directories. Minimal context loading, explicitly designed to only load essential data into the LLM's context window, expanding it as needed by following dependency trackers. Persistent state, using the VS Code file system itself to store context, instructions, outputs, dependencies, basically the external brain.
It even mentions a mandatory update protocol, MUP, for maintaining state integrity. That sounds very much like the need to keep the roadmap file synchronized.
Exactly. And it lists a modular dependency system, contextual keys, called key info for better tracking of information snippets, and hierarchical dependency aggregation. It's all there.
So this CRCT framework essentially operationalizes the whole multi-file structured external brain concept using standard development tools.
Yeah, the project structure is shown in the READM, with directories like ClineDocs containing specific files for things like activecontext.md, changelog.md, userprofile.md, progress.md, plus subdirectories for prompts, templates, utilities. It really mirrors the kind of file organization we saw described in the roadmap system. It demonstrates very concretely how this approach can be implemented using just a file system and Markdown.
So this confirms it's not just an interesting one-off experiment. It seems to be an emerging pattern, a viable and actively developed method for managing LLM context effectively on complex, long-running projects. It shows these ideas are translating into practical tools and methodologies for building more sophisticated human AI workflows.
Okay, so let's try to synthesize all of this. We've gone through the structure, the individual files, the AI's own thoughts, even a real-world example. Bringing it all together, what does this deep dive into an AI's external brain really mean for you, the listener, the learner out there?
Well, I think the core concept, the big takeaway, is the creation of this sophisticated distributed knowledge base, one that's specifically designed for an AI collaborator to use effectively. By breaking down all that messy, complex project information into specialized interconnected files, and then by assigning the AI these explicit roles and directives tied to interacting with those specific files, this system manages to work around those fundamental limitations of current LLMs regarding persistent state and their finite context windows.
It essentially transforms a stateless text predictor into something more akin to a context-aware, role-playing project participant.
That's a great way to put it. And it really highlights that leveraging AI effectively for complex, ongoing tasks isn't just about crafting the perfect single prompt anymore. It's increasingly about designing the environment, the structure, the whole information ecosystem within which the AI operates.
You're designing for intelligent collaboration.
Exactly. You're deliberately leveraging the AI's strengths, its ability to process vast amounts of text quickly, adopt different personas, generate text or code based on detailed context, while simultaneously using the structured externalization technique to mitigate its known weaknesses, like its poor memory, its lack of consistent state, and its potential to misinterpret or hallucinate without strong guardrails.
And the power of this core idea, structured, externalized knowledge, with role-based interaction, it feels like it extends way beyond just software development or game design, doesn't it?
Or absolutely, the fundamental principles here.
Yeah.
Structuring complex information across linked documents, defining specific roles or perspectives for interacting with different parts of that information, using an external system for persistent memory. It can be incredibly powerful in almost any field where you need to manage vast interconnected information and you want AI to help you make sense of it.
Like what? Give us some examples.
Well, think about academic research sifting through hundreds of research papers to synthesize findings. An AI using a structured system like this could potentially keep track of arguments, evidence, methodologies across papers much more effectively. Or think about managing the intricate details, documents, and timelines of a complex legal case.
Okay, yeah. Legal discovery seems like a prime candidate.
Or organizing the world-building notes, character arcs, and plot threads of a really sprawling creative writing project, like a novel series or a complex screenplay. Or coordinating the myriad details, vendor contracts, schedules, and contingency plans involved in large-scale event planning.
Even just personal knowledge management, right? Imagine building your own sophisticated, searchable, AI-navigable external brain for all your notes and ideas.
Exactly. It offers a potential shortcut maybe, to being genuinely well-informed on a complex topic, not just by having an AI summarize things for you, but by providing you with a clear blueprint for how to organize and access that information yourself. You, the listener, can look at this system and see how breaking down knowledge into logical categories like vision, blueprint, process, status, technical details makes even daunting complexity feel more manageable and understandable. That structure is valuable whether you're a human or an AI trying to make sense of it all.
It definitely provides some aha moments. It demonstrates a concrete, novel way to tackle that feeling of information overload and leverage AI for deeper, more sustained, more complex tasks than just simple Q&A. The structure itself, the breakdown, is an insight into managing complexity in almost any domain.
And hopefully, it empowers you, the listener, to think differently about how you might structure information when you want an AI to help you with something big and complicated. Instead of just pasting everything into one impossibly long prompt and hoping for the best, how could you create your own rudimentary multi-file brain for an AI? Maybe just using a few linked documents or structured sections within a single large note.
What documents or sections would represent the different facets of your project or knowledge base? What roles or perspectives would you want the AI to adopt when interacting with those different parts? It makes you think about information architecture for AI collaboration.
And finally, I think the system, through its explicit warnings and directives and reinforced by the AI's own feedback on potential misinterpretation, really highlights the absolute ongoing importance of human oversight and carefully structured inputs when working with these incredibly powerful but still fundamentally limited AI tools.
Those critical warnings about not making assumptions, the explicit mitigation strategies listed for LLM-assisted misinterpretation, the emphasis throughout on human review and using the documents as the source of truth.
Mm.
They aren't just formalities, are they?
Not at all. They are essential safeguards. They acknowledge that the AI, even when operating as a capable collaborator within this well-designed structured system, is still ultimately a tool. A very powerful tool, but one that requires human guidance, validation, expertise, and critical thinking to ensure its outputs are accurate, relevant, and truly helpful. The human remains indispensable in the loop. Hashtag tag outro.
So, what a journey. We've taken a really deep dive today into this fascinating multi-file roadmap system, this concept of an external brain for an AI. We navigated the high-level overview, explored the project's core vision, delved into the incredibly detailed technical blueprint, understood the development process and the dynamic live status tracking, examined the technical performance considerations, reviewed the historical log of completed work.
We even got to see the AI's own surprisingly insightful and positive review of the framework it was working within, and looked at how these ideas are being implemented in real-world tools like the CRCT framework.
It really feels like this deep dive shows a tangible, promising path forward for tackling serious complexity using AI. Not just working with AI as a simple assistant doing isolated tasks, but by fundamentally redesigning the environment and the information structure for the AI to work within, turning its inherent limitations regarding memory and state into opportunities for more structured, more reliable, and ultimately more effective collaboration.
The fascinating approach really shifting the focus from just the AI model itself to the entire system of interaction.
It really makes you wonder if externalizing an AI's memory into a structured multi-file system like this and giving it these explicit document-specific personas or roles can make it such a demonstrably more effective project collaborator. What other cognitive challenges currently facing AI could potentially be solved, or at least significantly mitigated, by fundamentally changing how we provide them with context and how we structure their interaction with information?
Where else might designing an external brain like this prove to be revolutionary in the future of human-AI collaboration?
A question that could reshape work, research, creativity, a lot of fields, potentially. Something for you to definitely mull over.
A great thought to end on.
Thanks for joining us for this deep dive.